Examples then from English. For example, if you take in English, each letter is independent token, but then, next one. They have a specific location. If you take a letter like T, for example, it can come with A, E or O, but you don't have words with TX or TZ and so on and so forth. So clearly, signs have preference about who should come next to them. Next one. Similarly, Q, for example, always comes with U. There is only one out of some 7, 8 odd examples where Q and U don't come together, but essentially they come together. Next one. The same thing you can do for Indus script. Next one. Okay, so for example, for English, I can say A to Z, all the alphabetic letters, and I can say that A following A has a certain probability, A following B has a certain chance, A following Z has a certain chance, and so on and so forth. And I can make this matrix about which sign can follow which sign. The same thing I can do for English, for Harappan. Next one. For Harappan also I can do the next one. Actually skip this one. Next one. I can take all the 417 signs in Mahadevan's corpus against 417 sign and ask myself what is the probability that this sign will follow this sign. Write down that number. What for probability of this sign being this sign. Again write down that number. And I can create this huge matrix which I can now use to understand or teach computer the Indus writing. Next one. And we did that and we asked the computer to follow up and see whether the rules work well. Next one. Okay. What we use this to first ask the computer to understand what is written, what is the grammar of its writing, and then we gave it some unknown, some writing which was not very clearly done, and the computer came out with predictions, and I'll show you some of the examples. We can also now write an Indus-like text about what it say about the grammatical rules. Next one. And we can use variations in writing if there are any writing differences in various regions. If the grammar is different in different regions, this kind of test should be able to tell you. Next one. This is the kind of thing that we did. For example, there's a string in Mahadevan's corpus where he says he's not very sure about what the first sign is. We remove that sign and ask the computer to predict, and the computer says, look, it is most likely to be this, but it could be either of these two. Similarly, over here, Mahadevan has a corpus string where he's not very sure of what is here. We remove that, ask the computer, and computer says that is the correct sign. But for example, in cases like these, where we remove the middle sign which Mahadevan is not sure of because the seal is damaged, the computer says that this is the most likely predictions, but these two can also come. It essentially tells you that there is some amount of similarity in meaning of more than one sign in such cases. Next one. All this shows that Indus writing is clearly ordered, and it seems to have a certain specific set of rules which can be taught to a computer, and therefore there is very clear underlying grammar. Next one. And the last question, of course, is whether it encodes a language or not. So we did one more test. Next one. Okay, next. Which is to compare with other sign systems. Next one. We compared what is called conditional entropy, which is the amount of flexibility you have in writing a language of Indus writing compared to other writing systems, and I'll show you that example. Conditional entropy, just to get the word correct, is amount of flexibility. Like if you write a letter T, you can put A, E or whatever you want, but you can't put X and Z and things like that. So amount of flexibility that is allowed in writing is predefined, and that is the structure of writing, and you can use this quantity. Next one. Okay. The scripts indicate, and I'll show you the result, that we have an interesting similarity. Next one. This is the graph that we have. If you have a perfectly rigid writing systems where no freedom is allowed, every sign must have only a specific sign following it, you would expect that particular quantity to look like this. If the writing is completely random, where it doesn't matter what sign follows what sign, then you would have a structure like that. And what we have over here is that for Indus, Sumerian, Old Tamil, English, all of them, the amount of flexibility that you have is very similar. We haven't put data over here, but for computer languages the data comes over here. For non-linguistic other system, for biological system, the data comes over here. For computers the data comes here. And for linguistic systems, it all fits nicely with Indus writing. So our suspicion is that the writing is certainly language-like, even if it may or may not be an exact language. Next one. So what does all this show us? Next one. It shows that Indus script was found on a variety of objects, several sites, and spanning over 1 million kilometers and so on and so forth. Next one. The sequencing of sign is important in index text. Whoever wrote the text was specifically taught a grammar. He was told which signs to begin with, which signs to end with, and what could come in the middle. And play previous. The script has therefore a very rich syntax. It has enough flexibility to express a lot of variety of information, and yet it has sufficient rigidity so that the meaning is not arbitrary, and that everybody would understand what any given writing string means, even if they have not met each other. And that is important. Enough flexibility to express all ideas, and yet sufficient rigidity that the rules can be understood without elaboration. The end result is that we can write in index script, but we can't read what is written because we don't know the meanings of those individual symbols. Last slide. These are the collaborators with whom worked. The work, of course, is inspired by Mahadevan's earlier work, but this is the group of collaborators with whom we have done the work that I presented over here. Thank you. Information. What I mean is, if you give me a string, take Harappan symbols, just write any symbol in random order, I can tell you whether that writing would be something that Harappans would have written or they would not have written, because, for example, this sign cannot appear at this location, it must appear at the end, or this particular sign cannot appear at the end, it must appear in the middle. Not only should it appear in the middle, it must have only specific signs as its neighbors and all that. That much I can tell you. So if you give me a fraudulent Harappan seal, I can check and tell you whether it is fraud or correct. In that sense, I can write. But I cannot read because I am still avoiding understanding the meaning of interpreting the meanings. Yes, sir. Not yet, no, sir. Not yet. What will happen, by the way, this work that we have done will never lead to an interpretation. What we will have to do is, once we have all the tests, we will take interpretation like what Dr. Parpola has or Mahadevan has, and see whether their interpretation of, say, 50 odd signs is correct in sequencing and ordering and relative frequency of signs. If he says this particular sign means a city and this particular sign means something else, whether those two signs can come together or not, or whether do they come together or not, those kind of things we can check. So this will not lead to interpretation on its own. Interpretation will have to be done by others. We can test whether it is correct or not. We can control the interpretation, yes. Correct.
Yeah.
Correct. Yes. But Mahadevan typing is very particular. Okay? And that type structure we now know. Now we can compare with any language model.
Yeah. Excuse me, sir.
Yes, sir.
The persons who are really saying now in the script is not a language at all. It's just a gibberish.
Correct.
How do you really meet?
I think this paper should put an end to that controversy. That
but then your earlier papers, they have been really challenging.
Yes,
saying that in terms of conditional probability, it's all. They have their own reservations.
Yeah, that is true. There have been people who have said, okay, one of the reasons why we went through such a rigorous testing is that we wanted to answer this question. There is a paper with some minimal statistics trying to show that it is not a script. So we first started to check that. Then we found that what they are saying is not really correct at all.
They have really doubted on that graph where you have really
correct. So we first
onto that.
Yes, that's right. So we did various tests. The test that we published in science paper, the one that was conditional entropy, they initially tried to say that it is hocus pocus.
Yeah.
Then they tried to create a false data. They completely failed to do that, in the sense that we have published our paper in true. Yes, that's right. Okay, what we have, No, the point is well taken that there were millions